Assalamualaikum and hi to everyone. We are from AS1204G. Today, our group will be presenting about Glycerol for code CHM301. So this is our group members. Nur Alia Akila, Nik Syahidatul Harifah, Fatin Shazwani and Amila Fadlina. What is glycerol? Glycerol, also known as glycerin, is a simple polyol compound or triol compound because it has 3 hydroxyl groups attached to its carbon. Glycerol has a wide range of uses in various industries. For instance, pharmaceuticals, cosmetics, hair care, food production, and in chemical industries. Glycerol is found naturally in both plants and animals. It is a byproduct of the breakdown of fats, specifically as part of triglycerides, which are the main form of fat storage in the body and plants. As we can see, this is the structural formula of glycerol. Glycerol consists of 3 carbon atoms, each carbon bonded to a hydroxyl group which is OH. Other common name for glycerol is glycerin. IUPAC name for glycerol is propane 1,2,3-triol. Next, homologous series for glycerol is alcohol, whereas glycerol's functional group is hydroxyl. Its chemical formula is C3H8O3. In plants, glycerol can be found as a component of lipids, specifically in the form of glycerol esters like triglycerides. It is also a part of the structural components of plant cell membranes and plays a role in energy storage. It is often produced as part of the metabolic process in seeds and other plant tissues where fats are stored. Glycerol can also be produced in small quantities during the process of glycerol metabolism in plant cells. It is particularly notable in plants that live in arid conditions because glycerol can act as protectant against dehydration by attracting and retaining water. For example, in plants like cacti and succulents, glycerol may accumulate during periods of water stress to help maintain turgor pressure and protect against desiccation. Moreover, glycerol also can be used to control plant diseases. For instance, it helps with resistance to several fungal diseases. Next, glycerol has been used in scientific research to promote tolerance or resistance to the main abiotic and biotic factors that affect plants. It also does not degrade in the environment and does not cause damage to human or animal health. In addition, glycerol application induces resistance to powdery mildew in wheat by regulating 2 important signals molecules, which are glycerol 3-phosphate, G3P, and oleic acid. Last but not least, glycerol also can reduce the oxygen level in wheat. Fun facts: glycerol is a reliable solvent for extracting polyphenols from food and waste products. There has been an increase in the application of glycerol over benchmark alcoholic solvents such as ethanol and methanol for natural product generation because of its non-toxic nature and high extraction efficiency. In animals, glycerol is an important part of fat metabolism. It is released during the breakdown of triglycerides, which is fats, into fatty acids and glycerol. This process is known as lipolysis. Glycerol is then transported to the liver where it can be converted into glucose via a process called gluconeogenesis, which provides energy for the body. For example, in humans, glycerol is released from adipose tissue when the body needs energy, particularly during fasting or prolonged exercise. The glycerol release is converted in the liver to glucose to provide energy for cells, especially in the brain. Not only that, glycerol also helps in maintaining blood glucose levels during periods of exercise by providing a precursor for glucose synthesis. Next, glycerol is a part of phospholipids which make up cells membranes in animals. Lastly, glycerol helps plants and animals retain water, particularly in harsh conditions. Fun facts: glycerol is a very effective cryoprotectant sperm cells and is commonly used in sperm cryopreservation. This is because during freezing, glycerol can lower the freezing point and protect sperm cells from damage. Besides, glycerol can help to balance osmotic pressure and reduce intracellular ice damage.
So now let's take a look at the benefits of glycerol across different areas. So first of all, for humans, glycerol play an important role in our daily life. It is found in personal care products like moisturizers, soaps, and toothpaste because it helps keep our skin and mouth hydrated. In pharmaceuticals, it is used in medicines such as cough syrups, capsules, and even as a mild laxative. And in the food industry, it helps to retain moisture in products like baked goods and act as a sweetener and preservative. While for living organisms, glycerol is especially valuable in scientific and medical fields. It is used in cryopreservation to protect cells and tissues when freezing by preventing ice crystals from forming. It is also biocompatible, meaning it is safe to use in the body and won't cause harmful reactions. Other than that, for environments, glycerol is a great example of a green chemical. It is biodegradable, which means it breaks down naturally without polluting the environment. Plus, it can be sustainably produced from renewable sources like plant oils and supporting eco-friendly production. And last but not least, in various industries, glycerol is used in manufacturing processes like producing plastic, antifreeze, and even explosives. It is also used in the textile and leather industry to soften and preserve the materials. So as you can see, glycerol is not just versatile, it is beneficial to our health, environment, science, and industry. Moving on to the next one. So there are a lot of uses of glycerol, which is a highly versatile compound found in many everyday products. So first of all, starting with medical uses. Glycerol is used as a gentle laxative in suppositories. It is also found in eyes and ear drops, where it helps to moisturize dry eyes and soften earwax. It is also soothing and hydrating nature, makes it useful in treating wounds and burns. Other than that, in pharmaceutical products, glycerol works as a solvent and sweetener. It also helps to dissolve active ingredients in medicines like syrups and capsules. While in the food industry, glycerol also acts as a humectant, which means it helps to keep the food moist. It is found in items like baked goods, chewing gum, and frosting, where it also prevents sugar crystallization and extends shelf life. And lastly, in hair and skincare products, glycerol is a key moisturizing ingredient. It draws water into the skin, helping to keep it soft and hydrated. In hair products, it can reduce frizz and enhance the softness and improve the manageability. So overall, glycerol is a simple yet powerful ingredient with a wide range of important uses in our daily life.
So next is a physical properties of glycerol. Glycerol is a colorless and odorless liquid. It also comes in a viscous liquid, and for the taste of glycerol, it is sweet. For the density of glycerol, it's 1.26 gram per cm of 20 degrees Celsius. Next is molecular weight for glycerol is 92.09 gram per mole, and boiling point for glycerol is 290 degrees Celsius, and for melting point of glycerol is 17.8 degrees Celsius. So the first chemical properties of glycerol is glycerol has high polarity. So glycerol is highly polar because it contains 3 hydroxyl groups, which are highly electronegative and can form a hydrogen bond. So the oxygen in the OH groups creates a dipole moment and making the molecule overall polar. So this hydrogen bond and the electronegativity differences between oxygen and hydrogen give glycerol its high polarity. So next is hygroscopic. So glycerol is also hygroscopic. It means that it absorbs moisture from the air. So the hydroxyl group in glycerol can form hydrogen bond with water molecule and allowing it to absorb moisture from the environment. So this property mostly useful in cosmetics and pharmaceuticals to retain moisture. For example, a moisturizer. So next, glycerol is also highly soluble in water and alcohol. So the presence of 3 hydroxyl group allow glycerol to form hydrogen bonds and making it highly soluble in water and alcohol. So this property is essential for its use as a solvent and in pharmaceutical formulation. So next chemical properties for glycerol is oxidation reaction. So oxidation reaction is to form various products from glycerol.
So mild oxidation of glycerol can yield compounds like glyceraldehyde and hydroxyacetone, which are useful in chemical synthesis. So strong oxidation can lead to the formation of acids such as glyceric acid. So lastly is esterification. So esterification is a reaction where glycerol react with acid to form ester. So hydroxyl group in a glycerol can react with a carboxylic acid to form ester. For example, reaction of glycerol with fatty acids will produce triglyceride, which is the main component of fats and oil.
And I will explain about chemical reaction in glycerol. They have 5 chemical reactions. The first one is selective oxidation of glycerol. Selective oxidation is a way to turn glycerol into valuable product by targeting its hydroxyl group. If we oxidize the primary hydroxyl group, we get a glyceric acid which can become tetroic acid. Oxidizing the second hydroxyl group give dihydroxyetone of DHA is used in things like cosmetic. Full oxidation of all 3 groups from ketometolic acid. This reaction use gold or platinum catalyst on carbon and need oxygen to work. This process is useful because it adds value to glycerol, which is often a waste product from biodiesel. The second chemical reaction for glycerol is hydrogenolysis of glycerol. So hydrogenolysis is a process where we break carbon or carbon oxygen bond in glycerol using hydrogen gas. This reaction produces 2 main compounds, which is 1,2-propadiol, also called propanyl glycol, which is used in antifreeze and as a solvent. The second compound is 1,3-propanediol, which is used to make PTT plastic, which is a type of polyester. To carry out hydrogenolysis, we usually use metal catalysts like copper chromite or nickel-based system. This process helps turn glycerol into useful chemical industry. So for chemical reaction number 3, which is dehydration to acrolein, glycerol can also go through a dehydration reaction to form acrolein. In this process, 2 water molecules are removed from glycerol, producing acrolein, which is a chemical used to make acrylic acid and superabsorbent polymer like those in diapers. This reaction needs acidic solid catalyst and high temperature to work properly. It's a great way to turn waste glycerol into something useful in the chemical industry. For next chemical reaction, which is the production of epichlorohydrin. Glycerol can be used to make epichlorohydrin, which is an important chemical used in making epoxy resin. The process happens in 2 steps, which is the first step, glycerol react with hydrochloric acid to form dichlorohydrin. Then, the second step is dichlorohydrin undergoes dehydrochlorination to form epichlorohydrin. This glycerol-based method is more eco-friendly compared to traditional petrochemical processes, making it a sustainable option for the chemical industry. So for the last chemical reaction is carbonylation to glycerol carbonate. In this process, glycerol react with carbon dioxide to form glycerol carbonate. This reaction need a catalyst and it useful because it help us reuse our carbon dioxide, a greenhouse gas, while turning the glycerol into a valuable product. Glycerol carbonate can be used as a solvent and in polymer production, making it important in green chemistry. For conclusion, uh, glycerol is a useful chemical made from natural source like plant, biodiesel, and more. Because it has 3 hydroxyl group, it can easily change into many important products like medicine, plastic, and even explosive. Glycerol can go through different reactions such as oxidation, dehydration, and hydrogenolysis. By turning waste glycerol into valuable product, we help reduce pollution and support a greener, more sustainable future.
That's all from us. Thank you.